Okay, so we're now going to have a look at 8D. So imagine I said that velocity is given by t squared and sine t as a column vector. What would the acceleration be? Well, hopefully you would say that you were going to, first of all, differentiate them. Not integrate, sorry, differentiate them with respect to t. Okay, and you'd say 2t and cos t. Okay, so what's the idea here? The idea here is just moving on from the previous video, we can differentiate also with I and j or column vectors. Yeah. So here's our first sort of worked example where we're going to put that into practice. It says a particle of mass 0.8 kilograms. So let's keep an eye on that one there. Is acted on by a single force, right? Probably don't need to underline that. Relative to an origin, the position vector. Okay, so we've got R again because it's I and J, and that's a bit like displacement, isn't it? So we're sort of at the top of the pyramid of variable acceleration. So we're probably going to want to do some differentiation in this question. It says find the speed. So speed takes on a slightly different meaning here, doesn't it? Because we've got two dimensions. So we need to find velocity first, and then we need to do the magnitude of the velocity. So A is more difficult than it was in the previous part of the chapter. So let's differentiate first, and we're going to say that the velocity is equal to, well, if I differentiate that, that's 6t squared. And then if I do this one here, this is a minus 25t to the minus 3 over 2 as a column vector. So at t equals 4, okay, so at t equals 4, let's find out what that would be. So at t equals 4, the velocity would be, for the top one, that's 6 times 16, so 96. And the one underneath, a bit more difficult, that should end up being minus 25 over 8. So are we done? No, because speed here means that we need to find the magnitude of this, okay? So minus 25 over 8 squared. And if we do that, we're going to get, and it must be in meters per second, we're going to get 96.1. Okay, so nothing radically different there. We just need to be a bit careful when it says speed, really. Find the acceleration. Okay, well, you know what we're going to do here. We're going to differentiate this one. So for B, we're differentiating these ones here. So this should give us 12t. And then what's this? 75 over 2? 75 over 2t to the minus 5 over 2. So that's the acceleration. That's the column vector. When t equals 2, and it just says the acceleration here. It doesn't say the magnitude of the acceleration or anything. So I think we just need to plug it in, and that's it. So if I put t equals 2 in there, I get 24 for the top number, and for the number underneath, it's not very nice. I've got this as a decimal for whatever reason. So 6.6291. So a fairly horrible number. But unless it says magnitude of acceleration, you would just, the default would be, well, you think of it as a vector. So that's what you would do. And find F, and F is a force. So there we go again. This is the whole F equals ma thing. That's why this was highlighted, and we haven't used this one yet. So t equals 2 is the same time. So I can actually just use this one, can't I? Times by 0.8, I think. So for C, your answer should be 19.2 and 5.30 is what I've got written down. And 4 is a force, so we would write newtons. So that was the acceleration, and then that was the newtons. Pretty similar to the question before. Yeah. Let's do another one. So let's have a go at this one here. So I think this is one of the real questions at some point. Position vector. Okay, they've got a bit more going on, these ones. position vector relative to fixed origin, so that's the same as before. At time t, p is moving in a direction parallel to the vector. So moving, so this is about velocity, yeah? Parallel to minus I minus j. So this is the same as saying southwest. They might have said southwest as well. So there's a couple of ways of doing this one here. Let's have a go at doing this approach. So first thing I'm going to do is I'm going to differentiate, which should give me 3t squared minus 9t minus 24. And then on this one here, it's going to be minus 3t squared plus 6t and plus 12. Okay, so that's what the velocity equals, and you get some credit just for doing that one there. There's quite a few different ways of doing it. Let me just show you why, though. In reality, what we're going to do is we're going to set the I bit equal to the j bit. Okay, so that's the way that we're going to end up doing it. But if I did this year 12 strategy that you saw, like is parallel to, yeah? So if I said is parallel to minus 1 minus 1, can you see that you're going to get minus lambda and minus lambda? So all that happens here is this is another way of saying that the top bit is equal to the bottom bit. So that's why earlier in the chapter you've seen me sort of use that shortcut. I just set them equal to each other, and I've got the mark scheme for this, and that's actually kind of what they show in the mark scheme. So I think they're expecting you to just sort of realize that in this case. So we set them equal to each other, so we would get this one here. We'd make it a quadratic with a 0 on one side. So if you make the t squared positive, you should end up with this version of it. Okay, for the solving, depends on what it says exactly, the way that you would solve it, but here I don't see any reason to not use the calculator. So I get t equals minus 3 over 2 or 4. So that's not valid. So it's t equals 4. Okay, so find the value of t equals 4 on that one. Find the magnitude of the acceleration. Okay, so that's the difference. In the previous question, they just said find the acceleration. Here they're saying now find the magnitude of the acceleration. So, you know, use a bit of Pythagoras at the end. At the same time, so it means we can recycle. Can we recycle anything? No, I don't think we can actually. Because we're still going to just have to differentiate these and then chuck 4 in as our value, basically. Okay, so let's do part B. So that was our part A. For our part B, when we differentiate, we get a 6t minus a 9, and then a minus 6t plus a 6. So that's the acceleration. Then we're going to use t equals 4. And if we use t equals 4, we end up with 15 and minus 18. Okay, so if we do 15 squared, 18 squared, if we do that one there, we get root 549. And what is this? This is acceleration, which is 23.4. Okay, so actually not too bad at all, this kind of question. As long as you remember here how to deal with the whole parallel thing, that's really the hard part of the question. But as you're going to see, I'm sure in some later questions, they can get a little bit more difficult, especially when they start having particles that change direction and talk about maximum speeds and stuff. It can get a little bit more difficult. So I would say this is a relatively nice one. But the main idea is you just sort of handle them separately. And that you can differentiate them even when there's an I and a j.